Welcome to this explainer. If you're building microservices in Spring Boot, you've inevitably run into a major architectural roadblock. How do you get your services talking to each other, efficiently? Choosing the right Spring Boot client for microservice communication is a huge decision. It literally impacts your code's readability, maintainability, and overall flexibility down the line. So today, we're going to break down this exact problem by looking at the three major contenders. Okay, let's dive into this. As a developer, you're faced with a pretty central problem, navigating between RestTemplate, RestClient, and Feign Client. Which one is the right tool for your specific use case? Now, fundamentally, they all do the exact same job, right? They send HTTP requests from one service to another. But the way they handle that job is drastically different. Finding that perfect fit for your project architecture is exactly what we're going to solve right now.
Here is our agenda for today. First, the synchronous baseline. Second, RestTemplate, the legacy tool. Third, RestClient, the modern replacement. Fourth, Feign Client, the declarative way. Fifth, comparing the three clients. And finally, number 6, the final decision.
Section 1. The synchronous communication baseline, setting the foundation for all three clients. Before we really compare them, it's absolutely crucial to understand that RestTemplate, RestClient, and Feign Client are all primarily used for synchronous blocking communication. Let's say you've got an e-commerce platform. You have an order service and an inventory service. When a user tries to place an order, the order service has to ask the inventory service if the product is actually in stock. In a synchronous process, the order service sends that HTTP request and then it just waits. It's completely blocked. If the inventory service takes, say, 5 seconds to respond, the order service sits there doing literally nothing for 5 seconds. All three of our clients operate on this exact blocking model. So if they're all synchronous, what's the big difference? Well, let's trace the evolution. Section 2. RestTemplate, the legacy tool, the old way of making HTTP calls.
Now, what's really interesting about this slide is the maze-like structure we're looking at. This represents the imperative style. See, RestTemplate forces you into an imperative programming model. That basically means you have to manually tell the system exactly how to handle every single part of the request. You inject your RestTemplate configuration, and then you have to dig through this massive list of overloaded methods, things like get for object, post for location, or post for entity. You're manually mapping out the exact instructions for the request execution. Now, for a simple GET request, it might look okay, but the moment you need to add custom headers, auth tokens, or a complex request body, your code base turns into a complete maze.
Because of this imperative style, RestTemplate comes with some pretty massive pain points: high boilerplate code and highly manual request handling. It just makes your codebase notoriously difficult to extend and maintain. In fact, if Spring wants to add a new feature, they have to update a massive web of overloaded methods. Because of this architectural bottleneck, Spring has officially put RestTemplate into maintenance mode. It is effectively deprecated for brand new projects. Seriously, if you're building a brand new microservice today and using RestTemplate, you might want to rethink your life choices. If you've got a legacy application that already uses it, sure, Spring still supports it, but you definitely shouldn't be writing new services with RestTemplate. Section 3. RestClient, the modern replacement. A cleaner, modern approach to HTTP calls. So, the secret sauce behind RestClient is that it utilizes a Fluent API. Instead of that messy, imperative web of overloaded methods we just saw with RestTemplate, a Fluent API uses a really elegant architectural style called method chaining. This lets you construct your HTTP requests by linking methods one right after another in a highly readable logical sequence. It dramatically cleans up the code base and makes it instantly obvious what your code is actually trying to achieve.
Let's move to and see how this builds in practice. When you write a RestClient call, you follow a simple, sequential chain. First, you define the method, simply typing .get or .post. Second, you chain .uri to tell it exactly where to send the request. Third, you execute it by chaining .retrieve. And finally, you convert the result by chaining .toEntity, passing in your desired class type, like an inventory object. You can easily just slip headers or body definitions right into this chain. It's clean, it's elegant, and it's a massive leap forward from the legacy approach.
Section 4. Feign Client, the declarative way, magic-like microservice communication.
To use Feign, you first need to bring in the OpenFeign Spring Cloud dependency, but once you do, you unlock the declarative style. And guys, this is a complete paradigm shift. Instead of writing out the execution instructions, whether imperative or Fluent, you simply declare what you want using an interface, and Spring literally handles the rest behind the scenes. You don't provide the manual implementation at all.
The advantages here are crystal clear.
With Feign, you create a public interface, annotate it with @Feign Client, provide the target URL, and then define methods that look exactly like your standard REST controller mappings using @getMapping or @postmapping, and that's it. Zero manual request building. When you inject this interface into your order service, calling the inventory service looks exactly like a local simple method call. You just write inventoryClient.getInventory. It hides all that HTTP complexity, giving you absolutely the cleanest architecture for microservice to microservice communication.
Section 5. Comparing the three clients. The ultimate feature showdown.
Comparing these side by side, let's look at the styles we just talked about. RestTemplate is imperative, RestClient is fluent, and Feign is declarative. Notice the boilerplate column here. RestTemplate gives you high boilerplate. RestClient lowers that to a medium amount. But Feign? Absolutely none. Just an interface. This translates directly over to readability, where Feign easily takes the crown as the absolute highest. However, pay close attention to that final column, flexibility. Because RestTemplate and RestClient require you to manually build the request, they actually offer high flexibility for complex, highly customized configurations. Feign trades away a little bit of that flexibility to give you its incredibly clean, zero boilerplate experience.
And this brilliantly illustrates the core philosophy of these tools, as summarized right here in the source material. Feign improves developer experience, while RestClient gives more flexibility. This is the fundamental trade-off every developer has to weigh when designing their microservices architecture. Do you want an incredibly fast, clean coding experience, or do you need deep, customized control over the HTTP request?
Section 6. The final decision. When to use which client. So the crucial point is this definitive three-part strategy for your tool belt moving forward. Number 1. Default to Feign Client. If you're doing standard service-to-service communication within a modern app and you want a clean, highly readable codebase, use Feign. Number 2. Reach for RestClient when you have special cases. If you need fine-tuned custom control, complex headers, specialized logic, or custom transformations, RestClient's Fluent API is exactly what you need. And number 3, restrict RestTemplate exclusively to maintaining legacy applications. If you're starting a new service today, RestTemplate should simply not be in your codebase. Now, we've solved the synchronous communication problem today, but as your microservices scale, you might be wondering, what if my order service simply cannot afford to sit blocked for 5 seconds? What if you need a non-blocking asynchronous solution that doesn't rely on message queues like Kafka or RabbitMQ? Well, that opens the door to reactive programming with Spring Web Flux and the asynchronous web client, which is a completely different paradigm. Are you ready to take your microservices to the next non-blocking level? Think about how that might reshape your architecture entirely. Thanks for joining me on this explainer, and keep building brilliant systems.